After combustion, let's look at some reaction that is only specifically for alkane. The reaction depends on the functional group. We know alkanes are saturated. Saturated means to the maximum. And saturated means a single carbon-carbon bond. That's why it makes it quite unreactive. Okay, in fact, of all the 4 homologous series, alkane is the least reactive of all. Reaction, substitution. Substitution with any group 7. Normally we do it with chlorine. And we need UV light or sunlight. Substitution would not happen in darkness. So from here what we can see is this. Can you see the hydrogen initially got 4, then now substituted by the chlorine. 3 hydrogen, one of it substituted by the chlorine. Every 1 mole of the group 7, one of the hydrogen will be substituted. So for example, if I got 2 chlorine, then out of the 4 hydrogen, 2 will be substituted with the chlorine. So this is substitution, right? It only happens for alkane. Another reaction that alkane will go through is cracking. Cracking is from big to small. There is no product. There is no fixed product. Okay, as long as the total number of carbon add up to the main one. 4 plus 18, 22 hydrogen. Or it can be just, see, they are all different products. It's just making sure that the number of carbon and the number of hydrogen is add up to the main one. So cracking is just a big alkane breaking into smaller alkanes. And one of the reasons that we do cracking is because smaller alkanes are more efficient in burning. As we mentioned earlier on, it's easier to burn, it's easier to catch fire, so it's in higher demand. So cracking normally is to suit or fit the demand, the higher demand of smaller molecules. So substitution and cracking is mainly for alkanes. Other homologous series will not.